Okay, folks, today we're going to continue on recognizing patterns and creating algebraic expressions for those patterns as we move forward in this unit. Yes, I'm going to acknowledge this. This is quite hard work. This is challenging finding those patterns. But today I'm going to try to help you find different ways to notice different patterns in that sense. And how can we identify those things a little easier. So in this pattern, I've actually color-coded it yellow and red. And you may notice what happens to the yellow blocks and the red blocks. Yeah, you're right. The yellow blocks always stay the same. There's always 3 yellow blocks mixed with 5 red, right? So we had 5 red here. Then we added another 5 to get 10 red there, and then 15 red there. And we could create a table of values where we have case number, and we could call these cases, case 1, case 2, case 3, right? And blocks. So I don't have a lot of room to create this table of values, but I'm going to, where case 1, 2, 3, case 1 has 8 blocks, 2 has 13 blocks, 3 has 15 blocks. And I just do that by counting each of the different blocks. Now is the tricky part of saying, let's create an algebraic expression for this. And the first part I start, the first thing I notice right away is these 3 yellow blocks. I always know those 3 yellow blocks are going to be there. Even in case 20, there's going to be 3 yellow blocks because they're not changing. The pattern doesn't affect the 3 yellow blocks. So I know my formula, blocks equals, I know there's going to be 3 yellow blocks. So I'm going to just add 3 to that. Now, how can I represent the red blocks? What do we notice about the red blocks? Awesome, they're increasing by 5 every time. It goes 5, 10, 15. Case 4 is going to have 20 red blocks, right? And there's going to be, it continues on there. Now, I might say, how many red blocks would, say, case 100 have? I really like this 100 case. It would have 500 red blocks. Because notice, this one has 5 red blocks, which is 1 times 5. This one has 10 red blocks, which is 2 times 5. And this one has 15 red blocks, which is 3 times 5. So the formula for this might just be 5 times n. Whoa, what is that n? What does that mean? Well, n just equals case number. N could be any case number. 1, 2, 3, 4, 5, or 100. It doesn't matter. But this formula is going to convert our cases into our blocks. That's what this formula is meant to be, right? So it's always going to convert our cases into our blocks. Oh, this should be an 18, not a 15. Sorry, I made a mistake. And I could show you. So for 3, let's put n3 in for n. So 5 times 3, right, plus 3. 5 times 3, this is equal to 15 plus 3, running out of room, equals 18 blocks. Look at that. When we put 3 into our rule or our formula, it spat out 18, which we know has 18 blocks. From this, I could continue to find different formulas or ways to use this. All right. I want you to pause the video and try finding the formula for this one before I do it. Okay, as you pause the video. So first thing is I'm going to just draw a table of values where we have case and blocks, where the case number is 1, 2, 3. And we have 7, 9, 11. Noticing this pattern, and again I color-coded these, what color of blocks remains the same? right? Right away in a pattern, I'll find what remains the same, what is not changing. You're right. It's the blue blocks. Now, blocks is equal to something plus 5, because we know blue blocks are always going to be there. Okay? Now, what plus 5? Well, here we have 2 yellow blocks, we have 4 yellow blocks, we have 6 yellow blocks, so it's increasing by a factor of 2. And if it's increasing by a factor of 2, it correlates or relates exactly with this, right? Or let's go this way. This times 2 equals that. Going up, I don't know why I went down, times 2 times 2. To go up into that. So right away we could say 2 times the case number. And some of you might be saying, whoa, Mr. Chase, how did you get that so quickly? And the reason I got that so quickly is through a lot of practice. I've done hundreds of these examples, and after hundreds of examples, you start realizing different patterns and notice different things, right? Am I expecting you to get it right away, first try every time? No, definitely not. Usually it takes a lot of trial and error before we could fully get the right answer, but the trial and error starts us realizing different things. Now, with this example, I want you to, and I'll go up and show this in the previous example, what if I said case 0? What would that look like? Case 0 would only have the 5 blue blocks, right? So, and look, this is equal to case 0. Looking up here, case 0 would only have 5 blocks here, right? No, it wouldn't. That's a lie. Case 0, sorry, I was too focused on the last one, would only have these 3 diamond blocks, right? The 3 yellow diamond ones. And look at case 0 has 3, and look at this number right here. It's the same thing. So right away we could start recognizing trends in case 0 and how that affects our formula. Again, I want you to pause the video and try this here. I always start off with a case is and blocks. But this time I'm going to put a 0 in and then go 1, 2, 3. Where 1 has 7, 12, and 17. How many blocks would case 0 have? You're right, only 2. Because the blue blocks stay the same every time. So I'm going to just say blocks equals plus 2. Okay, and the blue blocks stay the same every time. We notice the yellow blocks are increasing by a factor of 5 every time. So it would be 5 times n, where n is the case number, plus 2. Notice case 0 is 2. And then what is this going up by every time? It's going up by 5 every time. Look at that. Case 0 is 2, and that relates right there. And it's going up by 5, and it's looking there. So all these formulas are always going to be something times n plus or minus something. This is the layout of the formula always. Okay? I'm going to just do a couple more. I want you to look at these two, try to come up with the formulas on your own, and I'm just going to give you the formulas there. Okay, pause the video and solve it for yourself. So the first one, we know blocks equals, first I look at what's consistent. There's always 4 blocks, so that's going to be 4, right? 1, 2, 3, 4 is always the same. And what it's increasing by is the 2. So it's going to be 2 times the case number. That's what it's increasing by. And that's the formula you should have got there. This one's quite a bit trickier, but I noticed that the top pyramid of the block stays the same every time. And what's being added every time is this little pyramid type shape thing, which consists of 6 blocks. So the formula you should have got here is blocks equals 6 times the case number plus the 2 that's always on the top. Because you're adding 6 every time. So this 6 times the case number shows that you're adding 6 every time. Okay, so use this video and the thoughts I've used in this video to help you answer questions this week. I hope you enjoyed this. Please drop into my Google Meets whenever you have questions. Again, this should be hard. I am expecting a lot of you are going to be struggling with this, but biggest thing is trial and error. Do these questions. Try your best to solve for these questions. Take care and have a wonderful day.